Good afternoon. I'm Austin Montgomery with Senior Housing News, and I'd like to welcome everyone to today's webinar, VRF and Tax Incentives, What Senior Living Developers Need to Know. Before I introduce our speakers today, just a few quick housekeeping items. Your lines have been muted to ensure sound quality, and if you have any questions throughout the webinar, please feel free to submit them in the question section of your GoToWebinar window, and we'll save a few minutes towards the end of the webinar to answer as many as we can. And just as a note, this webinar is being recorded and will be shared with all registrants via email tomorrow. And thank you to Mitsubishi Electric for bringing this webinar to us today. And now I'd like to introduce our panelists. Joining me today, we have Randall Towb, who is the Senior Manager of Business Development and Senior Living at Mitsubishi Electric, and Cindy Blumenfeld, who is the Director of Engineered Tax Services, and George Matar, who is the Director of Operations Energy R&D at Engineered Tax Services. And now I'd just like to go over some of our objectives for today. And with that, we'd like to understand how decarbonization, rising energy costs, and modern construction requirements are driving the popularity of efficient systems such as variable capacity heat pump technology, and also explain the basics of VCHP, VRF operation and its benefits, and also explain which incentives and tax codes are available to senior living developers. And lastly, to understand the criteria for taking advantage of incentives and tax codes, especially 179D and 45L. And with that, I'd like to turn the call over to Randall.
Thank you, Austin. And thank you everyone for attending today. I'm going to turn my camera off so you don't have to see me, and I'll start to present. Okay, so we've prepared some really good content today on variable capacity heat pumps and the tax incentives for installing them. As Austin said, I will present for about 25 minutes on the mechanical systems and the electrical infrastructure savings to your buildings. And Cindy and George will present for about 25 minutes on the significant tax incentives available. And then we'll have about a 10-minute Q&A at the end of the hour. So let's start with how variable capacity heat pumps provide long-term benefits to, number one, your senior resident, number two, your staff working inside the community building each day, and number three, your net operating income, or NOI. Throughout our presentation, I will use the terms VCHP and VRF. VRF stands for Variable Refrigerant Flow and is a type of variable capacity heat pump, but with the added benefit of heat recovery and additional centralized controls, which we will describe in later slides. And again, please don't forget to submit your questions for our Q&A at the end of this presentation. Shown here are three competing priorities for owners, developers, and community operators. These competing priorities sometimes cloud the decisions up front or in design and planning stages of what is best for the building and operations budget long term. While variable capacity heat pumps are perceived as being more expensive than other types of HVAC technology, we are going to help you overcome false perceptions with a deeper look at why variable capacity heat pumps pencil out on first cost and why they are a slam dunk for long-term total life cycle cost. This picture of the Merrill Gardens Ballard Place community located in Seattle, Washington uses VRF HVAC technology throughout the entire building. It was installed in 2016 and is one of hundreds of senior living installations utilizing Mitsubishi Electric VRF across the US. No matter where you are located in the US, variable capacity heat pumps can work in any size building and any climate. We've been installing them with great success for decades. So when I say senior living communities, I'm talking about everything from high-rise buildings like this one shown in Dallas, Texas, to single-story buildings and everything in between. This Dallas, Texas community is a not-for-profit continuous care retirement community with a mix of independent living, assisted living, memory care, and skilled nursing beds. The majority of the community's square footage is for independent living, like many senior living communities. 100% of these two 12-story towers, including all common shared areas, are heated and cooled by VRF. It doesn't matter what type of senior living community you have planned, variable capacity heat pumps are a great fit. We know that in the vast majority of these communities, the operator pays the electric bill, so the energy consumption impacts the operator's bottom line. We also know the barrier to entry into senior living operation is costly with federal, state, and local licensing. The result is the owner and operators tend to hold on to the buildings longer because of these high cost barriers. Operating a senior living community is much more labor intensive than a standard multifamily residence building. These things you do up front will save you for decades in the future. Therefore, longer HVAC equipment life with lower energy use and maintenance is better on the total cost of ownership. I'm sure everyone is aware of how rapidly costs have risen since 2020. Construction materials have risen 35%, wage and benefits costs have risen over 5% annually, and in 2022 alone, cost of electricity increased 14% over 2021. This inflationary environment poses many challenges. However, it also creates opportunities for new technologies to deliver solutions. So what exactly are variable capacity heat pumps and what makes them so great for senior living, or really any commercial building? Well, let's dig into the details. Here are two pictures. The top picture has several VRF condensers. You can see they are larger, and each condensing unit is typically associated with multiple indoor units and has the capacity to heat or cool multiple rooms and floors inside the building. The bottom picture has smaller systems, many times called mini splits, and typically have only one or maybe two or three indoor units connected. These mini split variable capacity heat pump systems heat and cool a much smaller interior space compared to a single VRF system. Both are considered variable capacity heat pumps, and both types are used extensively throughout the US in all shapes and sizes of senior living communities. The inverter compressor is the heart of any variable capacity heat pump system. Inverters, or variable frequency drives, have been around since the 1960s and 70s and used in a wide variety of commercial and industrial applications. As the name implies, they vary the frequency, voltage, and amperage to an electric motor to control the output speed and capacity of the compressor and fans used in variable capacity heat pump systems. This graph is a good comparison between a conventional on-off HVAC system in red and a variable capacity heat pump in green. Note the hard start of the conventional system and the picture in the far right. It is an oscilloscope measuring the amperage used to hard start an on-off compressor or fan motor. Sir Isaac Newton once famously stated, an object at rest tends to stay at rest, and an object in motion tends to stay in motion. And I like to reframe that quote to, an inverter compressor in motion tends to stay in motion, and a resting non-inverter compressor takes a huge jolt of electric power to get it moving from 0 to full speed. Now note the smooth green line. It ramps up without the jolt of amperage needed for the hard start of a conventional on-off motor. The inverter varies the operation of the variable capacity heat pump compressors and fans and reduces energy used on startup. The soft start of the inverter also reduces wear and tear on the internal mechanical components of the compressor and fans, and is a key reason why our variable capacity heat pumps achieve a longer life of 20 to 25 years compared to the 10 to 15 year life of a conventional on-off HVAC system. Finally, note the top green versus red room temperature lines at the top of the chart. See the consistency of the green line temperature in the space using the variable capacity heat pump? This directly equates to resident and staff comfort, reduced energy and temperature swings, and more consistent airflow across the filters of the variable capacity heat pump, air handling, or indoor unit. Now let's get into the actual electrical uses of the two different systems. It is jolting, to say the least. Shown here are two identical senior living communities in Louisiana and Mississippi. They are sister buildings that use Mitsubishi electric Trane mini split style variable capacity heat pumps throughout all 100 resident rooms and 100% of the shared common areas such as admin offices, hallways, theater rooms, etc. The majority of the indoor units were horizontal ducted style that go above the ceiling, just like the one pictured on the bottom left. These are hidden and take up zero floor space or rentable square footage. One-to-one split systems like this are very common, they're a very common HVAC design in garden style and many 3 to 4 story senior living buildings. They are quiet and energy efficient, unlike conventional one-to-one split systems with jolt on and off compressor motors like we showed in red. So let's look at the basic system. These slides compare a traditional one-to-one split system on the top and bottom pictures. One connected condensing unit to one horizontal ducted indoor unit for both systems. The top system is a variable capacity heat pump with cold climate heating that doesn't require an auxiliary heat kit. The bottom is a split DX air conditioner with a 8 kW electric resistance heat kit. Both can handle the same air conditioning and heating requirements at 95 degrees summer temps and 5 degrees winter outside ambient temperatures. Let's do a comparison of the electrical requirements for each system, assuming that we have a 2-ton or 24,000 BTU capacity system. This size is very common in a 1-bedroom, 1 living room assisted living apartment of roughly 700 to 800 square feet in size. The top variable capacity heat pump cost approximately $1,500 more than the bottom system to the installing contractor. Now let's look at why the variable capacity heat pump is truly not a higher first cost option. First, the electrical amperage breaker sizes needed for the top variable capacity heat pump is 25 amps. The electrical amperage breaker sizes needed for the bottom split DX with the 8 kW heat kit is 75 amps, 3 times higher. Since breaker size is not the total picture, let's look at the two systems' MCA or minimum circuit ampacity ratings. These are all standard ratings for systems. The variable capacity heat pump has an MCA rating of 20 amps. That's for both the outdoor unit and the indoor unit. The split DX with electric heat has an MCA rating of 59 amps. Again, almost 3 times higher. So what does all that electrical breaker and minimum circuit ampacity value mean when it comes to operating over a 12-month period? Well, we measured that exact scenario for a developer building a 162-unit, 4-story independent living, assisted living, and memory care community in Cape Girardeau, Missouri. Ameren Electric and TRC companies finalized the model and approved the rebate for the 162 systems included here. At the end of the day, the variable capacity heat pump systems without backup heat saved the building over 938,000 kilowatt hours when the building is fully occupied over 12 months. At 11 cents per kilowatt hour utility rate, the savings is over $103,000 every year on electric utility. When you remove that extra 50 amp circuit for each of the 162 systems, you can see another 75,000 to 100,000 in construction first cost savings. That is the conduit, the wiring, the labor hours, reduced kVA size of your transformer, all associated with the electrical infrastructure. We do not need that 50 amp circuit because the variable capacity heat pumps we are feeding 2 to 3 amps of the power needed for the indoor unit straight from that 25 amp breaker that's feeding the variable capacity condensing unit. So even without the 112,000 Ameren Electric rebate, we had an ROI of less than 6 months. So are you starting to see the perceived first cost is not that great or maybe even existent at all? Furthermore, we haven't even begun to talk about year 2 through 25 of operational savings. The total life cycle cost savings for the owner operator of this 4-story, 162 system community is over $3.5 million. And that is without any tax incentives or utility rebates. That is a substantial savings for a senior living community that pays the resident utility cost and holds onto the building long term. The NOI savings alone is worth designing around variable capacity heat pumps. The benefits The added benefits of more comfortable building and your residents and staff is harder to quantify on your rent rates and employee turnover rates, but it helps out all the same, excuse me. All right, so moving along, the total life cycle cost benefits for using VRF or variable refrigerant flow systems is even more profound for the owner and operator of senior living communities than one-to-one variable capacity systems. Here are several large campus senior living communities throughout the Midwest and Mid-Atlantic states. They use three-phase VRF with heat recovery throughout the entire campus of the 5-story buildings. For sake of time today, I'm not going to dig into the details of why VRF and heat recovery increase the savings for owners, because Mitsubishi Electric Trane, we have many more in-depth presentations that you can find online or by emailing me directly. I'll be glad to share them. However, I will point out that if we were to take that Cape Girardeau 4-story example where we modeled and compared the one-to-one splits, the savings using VRF would be even higher. The total MCA rating for all the VRF with heat recovery needed for that 162 zone building would be 30% less than the 162 quantity of one-to-one variable capacity heat pumps, and over 60% less than the 162 one-to-one split DX systems with electric heat. The key takeaway from this slide is VRF can stand on its own in any senior living building anywhere in the US without incentives. We have a track record of successes to put you in contact with other owners and help you design and install an award-winning community. So let's look at the equipment again. This diagram shows a heat pump VRF. You can see the larger condensing unit connected to multiple indoor units. In fact, you can connect up to 50 indoor units to one condensing unit using VRF. Also note, all of the indoor units have to be in the same mode at the same time with this type of heat pump VRF system. These types of VRF systems are excellent for large rooms or networks of rooms that operate on the same temperature or thermostat setting. Hallways or networks of visiting rooms, such as foyers and open rooms to the common hallways, are great for these types of systems because you can have all the indoor units controlled from the front desk or maintenance office or from off-site. No more multiple thermostats on the wall and multiple roof and wall penetrations for multiple systems serving these areas on each floor. So this next slide is VRF with heat recovery using an air source VRF condensing unit to the left. Notice the additional piece of equipment called a branch circuit controller installed inside the building and in between the VRF condensing unit and the indoor units. Just for reference, it needs a 15 amp breaker and has a 1 amp rating for its minimum circuit ampacity. Pretty darn low. This allows for simultaneous heating and cooling of each individual indoor unit. These systems are great for resident rooms where one VRF system can service an entire wing of the building. Think of the reduction in electrical wiring and breaker sizes now, not to mention all the roof penetrations comparing this to one-to-one split systems. These heat recovery VRF systems save you even more energy by recapturing waste heat from rooms in cooling mode and reusing that waste heat through the refrigerant cycle to heat other rooms. And anyone operating a senior living community knows that seniors need and want heat, and many times have their rooms in heating mode, even in the summer outside temperatures are warmer. Moving along, here's a VRF heat recovery using a water-cooled VRF condensing unit. You still get simultaneous heating and cooling from the single condenser and all the same indoor equipment as the VRF air source condensing unit shown earlier. However, now you get double heat recovery and even more free waste heat recaptured from inside the building that you can distribute to any space, whether it's a common or resident room served by the VRF systems. Water source VRF double heat recovery occurs from recapturing waste heat from both the water loop of the boiler and fluid cooler and the individual VRF refrigerant loops. The great thing about water-cooled VRF is the VRF condensing unit is much smaller than an air source VRF condenser and can be installed in a small mechanical closet that doesn't require any ventilation. It's building science at its best. We see many mid-rise and high-rise buildings throughout the US go into this style of water source VRF system. Let's take a look at the indoor units. The indoor units are plentiful in both ductless and ducted styles to meet any aesthetic requirement. They also come in a wide range of capacities to meet any size room or space, from resident rooms to large open areas. Variable capacity heat pumps in VRF work in extreme cold climates and weather events. We have more cold climate case studies and installation references for your design team with your project. Mitsubishi was the first company to introduce the technology to the US back in the 1980s, and we have the best infrastructure to support your project. First cost savings are abundant and vary by the type of VRF system you choose and the other type of HVAC technology you choose to compare it to. VRF beats 4-pipe and 2-pipe chill water hot water systems. It beats water source heat pumps and rooftop with variable air volume on first cost and long-term operating cost. VRF can beat or have a short ROI against traditional split systems like what I showed earlier, or even less expensive PTACs and VTACs. No matter what other technology we compare it to, we can help you model your unique building and accurately estimate first cost all the way through the year 25 of the variable capacity heat pump or VRF equipment life. We offer free support for your architects and engineers, construction management teams, and facility operation teams. I like to say, get it done right with the manufacturer, Mitsubishi, on site. All right, moving along, what about outside air or ventilation air when applying variable capacity heat pumps or VRF? Well, with any type of HVAC on a commercial building, ventilation air is required. The most common design we see for VRF or for senior living when using variable capacity heat pumps and VRF is shown here, a rooftop mounted dedicated outside air system or DOAS. No doubt they add cost to the building, but remember, equipment cost alone is not always the true measurement of first cost in constructing a community. So let's take a deeper look. Two rooftop DOAS units here are shown here in this diagram, one for each wing of the building. You can see the size of the equipment and the need for vertical and horizontal duct shafts throughout the building. Many competing designs use PTACs or packaged terminal air conditioning units to eliminate these large rooftop DOAS designs. Just remember, to bring in raw outside air into a building, you need to properly cool and dehumidify the air on warm and temperate ambient days, or preheat the air on colder ambient days. PTACs, VTACs, and newer VRP HVAC designs require outside air grills on the outside of the building at every resident room location. These types of packaged HVAC systems do not have the proper coil size to dehumidify or preheat the air properly. They bring in higher amounts of moisture or humidity into the resident and common area space, and again require breaker and switchgear sizes at 3 to 4 times the amount of a split variable capacity heat pump, especially in heating. So good luck using PTACs, VRPs on a 68-degree day that is raining. They are just not able to cool the raw outside air down to 55 degrees to properly dehumidify it, and then use electric resistance heat or an add-on reheat coil to warm the space needed for the comfort level of the resident. With PTACs and the like, the room is going to have high humidity. There is no one-size-fits-all approach. Your independent living resident space will require less volume or CFM of ventilation air than, say, a skilled nursing room with 2 beds. Shown in this diagram is a variable capacity heat pump condenser mounted on the roof that weighs approximately 60% less than the same BTU capacity of a rooftop mounted DOAS. With this split variable capacity DOAS design, we use refrigerant lines vertically from the roof to modular dedicated outside air units located on each floor. You eliminate the need for the space of vertical duct shafting and all the added cost of fire dampers and controls with that vertical duct shaft. You can tailor the amount of ventilation air needed for each floor or wing of your building with a reduced equipment footprint, equipment weight, and energy consumption, all the while properly treating the raw outside air during any time of year in any condition. High humidity in the interior rooms of a building make it uncomfortable for the residents and staff. High humidity fosters higher amounts of dust, allergens, and airborne pathogens in the interior air. And finally, high humidity reduces the life of your valuable interior furniture, flooring, walls, art, and other expensive assets. P-tax, V-tax, and the like are not the answer for a building's long-term outside air strategy. And again, you have the added electrical cost of routing an extra 50 amp electrical circuit to every one of those P-tax or V-tax with their electric heat kits. That circuit is not required with VRF or variable capacity heat pumps. All right, we're almost there. I'll hand it off to Cindy and George in just a minute. We have 2 more slides until we get to the good stuff on federal tax or federal energy tax incentives. Before we get there, I want to show you 2 new product innovations Mitsubishi Electric has delivered to the US market for commercial hot water heating and new innovative HVAC. First, the new Heat2O product shown here is a modular centralized hot water heat pump for any size commercial building. It is an all-electric and uses the same inverter technology I described earlier with our variable capacity heat pumps and VRF. Heat2O delivers 176-degree hot water using CO2 in the heat pump system, which is an all-natural refrigerant with a 0 ozone depleting potential. Heat2O is being installed in Boston, New York City, Seattle, Portland, and San Francisco as we speak. You can see the case study for the Bayview Tower installation in Seattle, which is an affordable seniors housing building that was retrofitted with Heat2O in 2021. Look for this product to expand into other US markets soon. Hybrid VRF is another innovation we are excited to launch in 2023 throughout the US. It is yet another variable capacity heat pump innovation from Mitsubishi Electric, which allows for low energy use and a modular design for maximum flexibility for heating and cooling any building anywhere in the US. As the US moves into a future of electrification at the home and commercial building site, these innovations help us use less electricity from the power generation site. And that's a good thing no matter what side of the macro energy policy you stand on. Furthermore, as building energy efficiency requirements become more holistic, all of these types of systems for heating and cooling or domestic hot water help the building's energy score. That helps you on utility rebates and the significant federal energy tax incentives that Cindy and George will describe next. So without further ado, please let me introduce Cindy Blumenfeld and George Matar from Engineering Tax Services. Cindy and George, take it away.
Thank you, Randall, and thank you everyone for joining. So as a brief background, because Engineering Tax Services is a unique firm, we're a professionally licensed engineering firm with a tax expertise. We do not file clients' tax returns. We strictly perform engineering-based studies primarily for federal tax incentives. Just so you know how we work, we always provide a detailed benefit analysis on any of the tax incentives we may be looking at, and then we advise our clients to consult with their CPA on how they can utilize these tax deductions or credits, because as you know, everyone is in a different tax position. We are very lucky to be joined today by George Matar, who is our Director of Operations for R&D and Energy. So I'm sure he's going to be jumping in during the Q&A time. So we're going to be covering cost segregation, research and development tax credits, 179D, deductions, and 45L tax credits are the hot topics. We could probably spend about an hour on each one of these, so this will be a brief highlighted overview on the latest and greatest updates. So since there's a lot to cover, I'm going to jump in and start with engineered cost segregation studies. A cost seg study is basically an engineering appraisal of the building for tax purposes. If you don't have a cost seg study done, your CPA would most likely depreciate your building straight line method, which is 27.5 years for residential and 39 for commercial. Cost seg studies have been around since the 80s. They were for the big buildings, like the $100 million buildings. Now we do them all sizes. Cost seg studies are not only approved by the IRS, but preferred. This is a full engineering breakdown of all the pieces, parts, and components of your building. we classify them into their appropriate bucketed class lives per the IRS guidelines into 5, 15, and 27 or 39-year assets. For example, carpeting, it's a 5-year asset. Why depreciate it over 30 or 40 years? It won't last that long. Pretty much nothing in your building will. So basically, we pick up your building like a dollhouse, turn it upside down and shake it, and whatever falls out is personal property because it can be removed, and we are able to accelerate it. This, by the way, applies to all types of investment real estate, including leaseholds and improvements, and we can even go back to prior years and catch up on any missed depreciation. Depending on the building type, we can typically accelerate and recapture about 30+% of the purchase price or build cost back year one, not including land. Land isn't depreciable. And in the next slide, I have a short video for you.
The Next Generation Cost Segregation Study. Cost segregation is a tax strategy that has been used successfully for years to help property owners lower their tax liability by accelerating the depreciation on fixed assets, like an office building, through properly identifying every component of that building as preferred by the IRS. But is there more to be found? Engineered tax services like Next Generation Cost Segregation Study looks beyond accelerated assets and into separate building systems, tax incentives for energy efficiency, disposition of items no longer in use, charitable deductions of materials eligible for donation, accounting for repair and maintenance costs, and even reducing liability insurance premiums with a detailed engineering appraisal. With cost segregation, instead of a $15 million property having a tax write-off of only $384,000 per year, the tax write-off could be nearly $1.2 million per year. Think of an office building like a tall box that holds many individual blocks. If you pull out the separate building systems, like taking a block off our building, those components can help property owners increase their annual write-offs. Building systems include fire protection and gas distribution, the elevators or escalators, the lighting, electrical, and HVAC systems, just to name a few. And other assets like landscaping, flooring, cabinetry, and special lighting and electrical would qualify for shorter depreciation than the building itself. Having this detail in one report creates a valuable tool for property owners to ensure IRS compliance, optimum depreciation, and additional write-offs each and every year. Real estate can be the best investment for wealth preservation when tax rules are applied.
And here's just an example of some of the assets that we can accelerate: plumbing, certain wiring, cabinetry, shelving, finishings. And I have a case study coming up. All right, so this is a senior housing facility. We were able to identify almost 20% in 5-year assets and a little over 15% in 15-year assets. So that brought us to 35%. So my 30% earlier was a little conservative, which turned out to be over $2 million year one, with a basis of $6.8 million. And I have it broken down in the next slide as a pie chart. You can see that we segregated out for land. Land isn't depreciable. And that's something we go through during the cost segregation process. The IRS prohibits us from determining land values. So we advise our clients, let's check your tax card, go back to an appraisal, loop in your CPA, and let's get the appropriate land value in there. So it's showing a purchase price of $7.6 million. We took out the $800,000 for land, and the rest gets divided into 5, 15, and 27 because this is residential. And in the next slide, it'll show the financial breakdown. So this particular building was placed into service in 2022. where we had 100% bonus depreciation. That means that we get to take the 5 and 15-year assets, add them up, and you get to take them all year one. Any buildings placed into service in 2023 will have 80% bonus depreciation, and the IRS will continue reducing annually by 20% until it phases out. So in this example, we were able to generate over 2.3 million in deductions. So the client would times that by their tax rate, and then that would be their net benefit. If all the deductions cannot be used up, meaning you don't owe the IRS that much money, anything left over rolls over to future years until utilized, so it's not lost. Another important thing to mention is abandonment studies, or we call them PAD, partial asset disposition. This is simply capturing the value of what is being disposed of in a renovation. What we can't accelerate in a cost segregation study is lighting, HVAC, and the building envelope, which is the walls, the windows, doors, roof, concrete. So for instance, if you install new lighting or HVAC in a building you purchased 5 years ago as a 27-year asset, that's 22 years of net book assets we get to write off. And I have a case study. This is actually a lighting case study. So this was a 100,000 square foot facility. They did a new lighting. By the way, can't just put in LED bulbs or just new switching. It has to be a full retrofit. But we need those as part of it as well. This is a 100,000 square foot facility. Their relighting cost them 150,000. They got some utility and rebates from the state. Their EPAC tax deduction, which I'm going to get to in a minute, was $60,000. Their abandonment was $90,000. That's the old lights they were throwing in the dumpster with a $90,000 value. So that's where we come in able to capture a value to that so that the tax advisors can write that off appropriately. So this is showing as an estimated 35% tax rate. Their actual net cost would have been brought down to $31,500. But if you ask me, it's even less because we're not even showing the utility savings that they're getting from the new lighting annually. So here's just we provide info needed forms. This is an example of an HVAC one. We have one for lighting, or if it's a whole building. Basically, we need to know what are you putting in and what are you taking out. And what you're taking out, we would want the year of that so we can be able to see if there's a value there to be able to capture the abandonment disposition. And we're able to turn around an analysis complimentary within a couple of days. I know we have a lot of designers on this webinar, so I wanted to quickly update you on the R&D tax credits. The research and development tax credit is one of the most substantial incentives under the current tax law, and this is a dollar for dollar straight tax credit, not a deduction as previously discussed. This credit is an economic stimulus to keep innovation and creativity here in the USA and to encourage job creation. The R&D tax credit has been around since 1981, but finally made permanent in 2015. 42 states also have an R&D credit. So if you qualify for the federal, we'll be able to get you the state too. To qualify for the R&D credits, your activities must be in the USA and technological in nature, meaning they rely on the principles of physical, biological, engineering, or computer science. When looking at R&D, we have QRAs and QREs, qualifying research expenditures and qualifying research activities. So what is it that you're doing that's in the hard sciences? And then the credit is primarily based on a bucket containing 3 amounts. The biggest thing in that bucket, 80%, is W-2 employee wages. We also include direct supervision, direct support. We can include 65% if you outsource to a subcontractor or an engineer, just as long as they are based in the US, and if there's any materials and supplies that are used and consumed. So we take that total number, and at the end of the day, your tax credit is about 8%, not including if there's a state credit, so possibly even double. And if you haven't taken advantage of the R&D yet, we are allowed to go back 3 open tax years to catch up. So moving forward to energy, 179D is the tax code for the Energy Policy Act of 2006. EPACT is the acronym, so all 3 names mean the same thing. This was a temporary incentive that didn't get much recognition. It was out for a few years, expired, reinstated, expired, etc. So the great news is they finally made it permanent in January of 2023, and they increased the potential dollar amount and included more eligible building types, such as nonprofits, REITs, religious organizations. This is a tax deduction for installing in new construction or renovated buildings and residential, that's 4 stories and higher, energy efficient systems. The tax deduction goes to the building owner or possibly the tenant. If they paid for the new lighting or new HVAC, they get the tax deduction. In the case of public and government buildings, since they don't pay taxes, the deduction is allocated over to the designer of record. So whoever the public entity signs off as the person or persons responsible for that design, and for those designers, we can also go back and capture from 3 prior tax years. An owner is not limited to a 3-year look back, or and a designer is also required to amend if looking back, whereas an owner is not. So as I mentioned, the IRS now made it permanent. However, they also changed the guidelines and added in a prevailing wage and apprenticeship requirement. So before 2023, to get this tax deduction, it was pretty much a straightforward energy modeling for new lighting, HVAC, and if it was new construction or pretty much totally rehabbed, we would be able to include the building envelope. So those 3 systems was 60 cents each for a total of $1.80 per square foot. And they actually bumped that up a couple of pennies for inflation. So to get this tax deduction, it's required that you install these energy efficient systems, and you have to prove the energy savings by having the building modeled by an independent, unrelated to the project, third-party engineer. And that's where we come in. We get the specs and the plans. We model the building using the IRS tax-approved software. It's required that a licensed engineer does an on-site inspection, looking and making sure that what was submitted on the specs and plans was actually installed. So now in 2023 and forward, we're looking at the whole building's energy consumption, and based on how much savings by what you're installing determines the deduction amount on a sliding scale. We compare this against an ASHRAE 2007 model. So that's a pretend model that was built to code in the year 2007. We need to beat that energy consumption by 25%, and then we get 50 cents a square foot. And you get 2 cents for every percent better that you get. If you reach 50% energy savings, you get $1. Now's where the bonus comes in. If the designers and contractors meet the prevailing wage and apprenticeship requirement, you can get up to a $5 a square foot tax deduction. And here's just a chart showing the breakdown of the sliding scale and with and without the labor bonus. So this prevailing wage map, you can find it on sam.gov, SAM, like Uncle Sam. The prevailing wages are determined by the counties. It varies very much throughout the USA. Some don't even have them, and some are surprisingly low. And I believe there's also a window where if a new construction or a renovation took place in 22, but not completed until 23, we are able to waive that prevailing wage requirement and go for that maximum of $5 a square foot. So we'll be sure to circle back with George on that. Here's just a couple of quick case studies from 2 memory care facilities that we did. We were able to get them over $155,000 in deductions. Okay, moving forward to 45L, which is now on a 10-year extension, the biggest extension ever, I believe. And they also increased the potential dollar amount and included more qualifying property types. It was, prior to 2023, a $2,000 tax credit, again, credit, not deduction, so even better, for highly energy efficient new construction or majorly rehabbed low-rise residential properties only. That's 3 stories and under. For 4 stories and higher, we would look at the 179D benefit. This benefit goes to the developer or owner, and you are allowed a 3-year look back if needed, and if so, you must amend. The 45L takes into account all aspects of the property's energy consumption, from electric, gas, windows, appliances, waters, and more. With the new changes, now we can include duplexes, single-family houses, mixed use, manufactured homes, and high rises. So a building may be able to receive both the 179D deduction and the 45L tax credits. And here are just a few case studies from some senior housing buildings we did. So not only did they include more building types, but they also increased the potential amount for up to $5,000 per door or dwelling. Again, depending on the prevailing wage, the building type, if the building is Energy Star or Net Zero. And I know we're leaving some time for Q&A, so I will pass the mic back. Thank you.
Okay, so I think I'm supposed to take this section back. Thank you very much, Cindy, for the details on the tax incentives. I'm going to keep this portion very quick because we already went through some of the long-term benefits of these types of systems. So I would like to go ahead and turn it over to Austin and to get into the Q&A. Or I'm sorry, Andy.
All right, thank you so much, and thanks to Cindy, George, and again you, Randall, for this content. So let's get right into it. So there are a couple of questions that reflect varying levels of familiarity with the material. So let's just go right ahead. So first, are there any building systems that don't qualify for cost segregation? And so this one I think we should direct towards Cindy and George to start. Oh, Cindy, you're muted.
Just saw that. Sorry about that. Yeah, for cost segregation, we break down all the pieces, parts, components. Even the long life components, like I mentioned, the lighting necessary for the operation of the building, the HVAC units, and the shell of the building, those are also identified in the cost segregation study. And then if there are any changes to them, that leaves the room for disposition. But it's a breakdown of the whole building. It's hundreds of pages long, down to the nuts and bolts.
George, anything you want to add, or you want to move to the next question?
With Cindy's interpretation.
All right, wonderful. Randall, we got some VRF for you, so sit tight. So let's move on to the next. So for 45L, I see that developers, builders, and investors can claim the tax credit. can each party claim it or only one? And then how is it decided who claims it? So Cindy, George, I think that's for you.
Yeah, I can take that one. So in order to claim the 45L, you have to be an eligible contractor, which means you have some investment in the property during its construction. Typically, that's some LLC that's formed. So the 45L is generated at the LLC level, and the tax credit's allocated depending on the ownership of that LLC.
Right. Cindy, you look like you're good with that response, so I'll go on to the next one. Randall, hold on, one more text question. So does the three-story residential buildings, do they qualify for 179 and 45L?
I can take that one as well. So I think with the change that the Inflation Reduction Act brought in, that's where for buildings placed in service in 2022 and prior, any three-story building, if it was commercial, that would be 179D. If it's residential, that would be 45L. So prior to 2023, 3 stories and less residential is 45L, 4 stories and higher is 179D. Now we move into the Inflation Reduction Act's changes for 2023 and forward, that building height limitation is gone. So any residential building can be applicable for 45L, and any 4-story or higher residential building can be 179D. Potential to get a combo of both on that type of high rise.
And George, on a mixed use building that is, say, partially residential or senior living with part, multifamily or not an age restricted or part hotel, you can take advantage of a portion of that built, the 45L in that residential portion of that building, correct?
Yeah, great question, Randall. Yes, because mixed use is very common where the first floor is commercial with residential on top. So at that point, we're just going to see what is the total building height, number of stories, to kind of devise a best tax strategy for that property.
All right, excellent. All right, so let's switch over to VRF for a second. So Randall, you'll take the first hit on this one. So earlier you discussed ERVs and DOAS, but aren't those just for bigger buildings with VRF? So how do you handle outside air if you're using mini splits?
So for a senior living building that is using like 1-to-1 mini splits or variable capacity heat pumps throughout the majority of the building, or any part of the building that needs ventilation, you have to have a dedicated outside air system or like an ERV to bring in. So the reason I spend a couple slides on that is we always get those types of questions, and kind of going back to the presentation, every building that requires ventilation air is you need to look at that building specific to how you're going to use it. And so we like to, again, really kind of break down, especially a senior living, you don't need as much ventilation air in, say, a 55 plus or age restricted apartment or independent living dwelling versus, it's like a skilled nursing type room. So really to look at it for each individual unit is the best way. And again, it really is unique to your specific building and your specific climate and your code. So really we like to, talk to you about those details up front and see what the best option is for your building, both from an outside air and from your comfort level of your building and for your residents and staff, and from an energy use and from your not just your mechanical equipment costs, but all of your electrical switch gear and circuitry that's needed for the system throughout the building. And that's really the best way to look at the building from a first cost perspective. And when it comes to outside air or heating and cooling the zone. Feel free to email me directly and I'd be glad to jump in with your specific project or projects and get our team of experts for those markets engaged with your design team as well.
Excellent. Next question. If you're using VRF in a high rise, is the 45L credit per dwelling unit?
Yeah, the 45L tax credit is based on a individual dwelling unit achievement. So if there's 400 units, you have potential of 400 units able to be claimed for the tax credit. The tax credit is obtained in the year each dwelling unit is first leased or sold. So if your building's placed in service in 2022, you might have kind of like a phased approach that maybe a third is occupied in 2022, maybe another third in 2023, and what have you. So there is a potential for the tax credit to span multiple years depending on first occupancy.
Right, excellent. Next question. What is the typical lifespan of a VRF system, and how does that impact tax strategies?
So I'll answer the first part, and I think George will take over the second part. But the typical lifespan of a VRF system is we have to rate it from AHRI. I think they rated it 15 years. We've got systems that have been running for 25 years plus in commercial applications in the US. The inverter compressor really is a soft start, so you don't get that big spike in energy to, that dims the lights in your house or resident room, or resident room when something kicks on that's going across the line. So that really helps the life of the equipment, helps it last longer. And then I'll turn it over to George for the tax part.
Yeah, thanks, Randall. Yeah, the variable capacity heat pumps model very well in both 179D and 45L studies. Because the 179D is akin to a 1-year accelerated depreciation, it models very well with a cost segregation study or even a disposition study, just depending on the life cycle. So when we're talking about new construction, these variable capacity heat pumps are a great fit for 179D. And let's say down the line, after, say, you think about doing a renovation, that's where maybe a partial asset disposition can come into play.
Okay, great. Are there facility square footage restrictions for 179D? I know you can do high rise, but what about low rise senior living applications?
Yeah, with 179D, the focus on the residential side is 4 stories and higher. So if you're a residential application for senior housing that's 3 stories or lower, we wouldn't be eligible for the 179D program. We would look to lean towards 45L.
Hey, George, I'm sorry to interrupt real quick. So if a building is more of like a skilled nursing community, is that classified, and it's single story, will that qualify for 179D, or does that still fit into the residential side?
No, that's a great question. If we can consider it more of like a healthcare hospital, maybe like that type of building typology, we might be able to qualify that under 179D.
Thank you.
This next question is about classification. So is a multi-story, multi-family building considered residential, or is it commercial?
I think that kind of goes back to one of Randall's earlier questions on, let's say, a 4-story building that was the first floor was commercial and has 3 levels of residential on top. For that application, we'd likely be able to capture both 179D and 45L. But let's say it's 1 story of commercial and maybe 1 story of residential up top. What we do is we kind of split the building approach. We delegate the square footage of the commercial facilities on that first floor toward 179D and the residential applications for the units on the second floor toward 45L. So we can utilize multiple tax strategies to kind of segregate the building onto what's the best energy program to maximize the tax benefit.
All right, great. Okay, so we're just about at the hour, so ask one more question. So if you are if you would like to start looking into incentives for installing these systems, how do you begin? So Cindy, George, maybe you want to hop in, and then I'll pass it off to Randall.
Sure. I mean, we've partnered with Randall for a long time, and most of the tax benefits are post-construction. So at the front end, we're happy to offer a complimentary kind of benefit analysis for your design planning, your tax planning, on saying, I have a new construction building. This is kind of what I'm planning for. but most of our tax strategies will come in after the building's placed into service or after the project's completed to best analyze and capture the tax strategies then.
All right.
Yeah,
Cindy,
on the HVAC side, if you're looking at our type of technology, we'll not only help model it, but then also bring the design drawings or conceptual drawings, to Cindy and George to have them just verify that the HVAC piece will work. And I've never not seen any of our variable capacity systems not qualify. And I want to point this out because there's some confusion. We have some of our smaller our mini split variable capacity systems that are rated for Energy Star, and some, like the ones I showed on this slide, that are one-to-one ducted systems that are not Energy Star rated. The thing for this 179 or this 45L Energy Star multifamily is our non-Energy Star rated equipment still qualifies or helps you qualify on the HVAC portion because they are so energy efficient. And so again, I've never, sort of use the double negative here, but never not seen variable capacity heat pumps, mini splits, or VRF not qualify for these types of incentives.
all right, great. Okay, well then let me pass it back to Austin for some concluding remarks.
Thank you. Well, we've reached the end of our time today. I just want to thank Randall, Cindy, and George for sharing your insights with us today. And thanks again to Mitsubishi Electric for sponsoring this webinar. And of course, thank you to our audience for tuning in. Everyone have a great day. Thank you.
Thank you.
Thank you.